So Mark Richardson, our Education and Outreach Officer at the McDonald Institute, along with his skilled PhD in physics, is going to be drawing us into the world of version control and the discussion. And I know you're going to offer us a little bit of a layout of both this session as well as how you'll roll out sessions 2 and 3. So feel free to ask questions, take notes, and I will turn it over to Mark and welcome you. Thanks so much.
Thanks a lot, Alex. Yeah, and so I know there's a lot of different people here with maybe different experiences with version control. And one of the benefit of breaking this up into 3 points is, or 3 parts, is I'm going to really be coming into the ground level, and we're gonna work up from there. And so I hope, you know, for some of you, this could very much be a recap. If you're like me, every recap with Git is useful. You find something useful every time. So I hope that this is still useful for you. Throughout today, this is going to transition from me just kind of talking with slides to being much more interactive, where I encourage you to be following along at home. At that point, I'm going to be really engaging with the Software Carpentry website. They have basically made a lesson about this, which I'm going to follow while bringing in some of my own experiences. And, you know, that's good in the sense that, like, you guys can kind of return to that after the fact and connect to it. And so, you know, we have on the order of like an hour and a half that we allot for this session. I probably will use close to all of it, but because of these 3 points, I keep saying points because it's CPT, because of these 3 parts, we have that buffer that you know, as questions come up, we might not get quite as far as I expect to get today, and then that gets moved on to the next part and in the next part. And I think that's good. That means we're gonna learn the most, and maybe you might very well ask me something I don't know, and there might be somebody else in the room that has experienced that, or we'll just trial and error through it together. And so I do want to highlight just some groundbreaking rules. Like I said, you know, I do encourage you all to be muted, but please share your camera if you feel comfortable doing so. It certainly is a little bit more engaging for me. Feel free to write questions in the chat. If you do have a question or often a bug of some kind that comes up, raise your hand and we can work on that together. This session is being recorded. You probably heard the voice as you came on. So these resources are going to be made available after the fact to you and to others that are going to be engaging asynchronously. Right, and I believe it is the case. It might not be the case. It is the case. No, it is not the case. Currently, I've just maybe made the request that things are live transcript design. Very good. So if somebody wants, if you would like a live transcript of what I'm saying, that is an option that should be available to you now. I don't need that though, so I'm going to disable it for me. Somehow. Oh no, hiding behind Windows. And as always, you know, please be patient and understanding. This is always a little bit different doing these virtually. That's very good. This is also my first time really following along with the Software Carpentry tool, and so yeah, I'm curious to see how exactly that goes. We'll see, and we'll be asking for feedback at the end of this. And so really are going to be looking for that feedback, because we can implement things that are working or things that aren't working in those following sessions on version control and Git. Alrighty, so my plan for today, with the time we have, is we've done the preamble. We've already checked off the first thing on the list. And so we can dive right into really what is version control. And Alex, thanks for reading the abstract again. I think that's useful for contextualizing what we're doing today, but we can go over that a little bit more and make sure everybody's comfortable with it. And then I'm going to turn to a simplified parable, which maybe some of you have heard the Git parable before. I'm going to revisit it. I think it is useful, and I'll motivate why we're doing that. And that's going to tie us into the specific example that these sessions are going to focus on in the context of version control, which is the software Git. It is by far the most used in basically every industry. For a while, there was neck and neck between Git and Mercurial, and I think Git has basically just won the race. And I don't suspect that there will be another one coming up soon. And then diving into the software carpentry, we're going to go in and do a little bit like tools from the couch sessions, which are very much hands-on, working on this together. We're going to go through those steps as if we're starting from scratch, engaging with Git. So making your first repository, understanding how you track changes, and explore the history of your code. And the ignoring things will take us about 5 minutes. I have a feeling it's going to be moved to the next session. And then moving on, we'll then proceed to talk more about collaboration, how you can work with other people, and how you can merge in what you guys are all doing to probably a shared bit of a shared document like software or a paper. So again, all of the resources today are mostly drawing from Software Carpentry. I recommend checking that out. They have lots of other resources for different software. Some familiarity with Bash could be useful, but it's not necessary. The slides for today will be put on the McDonald Institute website, and all the resources and information for the video as well. And then you'll be engaging and registering to be able to have access to that material, just so that we know who's using it. And so before we begin, going forward, we should be the case if you really want to fully engage with this and I think get the most out of it, I recommend, and we had it in the calendar invite, you should already have Git installed on your computer. I linked to a resource that can do that, depending on, assuming you're either on a Mac, a Linux, or a Windows machine. And you should have made GitHub accounts at github.com. The GitHub account will not actually come in to today's session. So if that's something you haven't done yet, that's fine. But it'll be useful going forward. So just before we go, I'm wondering if there's any questions at this point about just kind of the framework of how today's session is going to run. I'm seeing no hands. Silence is golden. And so we'll move forward. So what is version control? Curious to know, like, what do people think of when they hear version control? And here, you don't need to raise your hands. You can put it in the chat maybe.
Controlling different versions of a software and keeping track of it.
Controlling and keeping track of different different software. Grown up Control Z, and I would say Control Y or Control Shift Z, Connor. The redo button, I think, is also part of version control. Having people collaborate on a project such that content can be managed. Overriding, throw it back up. Very, very good. Okay, so I have a number of things here, which is being reinforced with what you guys are putting. And so I think kind of the Control Z sentiment that Connor shared is the go back and importantly forth between different versions of a code or document. And so that allows you to quickly see, you know, the changes. What were they? When did they happen? Who was responsible for that bug that is in my code or in, you know, that nonsense that's in my paper manuscript? And ideally, why those changes happened. And you want to do it cleverly. You don't want to just have, I mean, I'll show you a bit of a blame is very important, Connor says. You do want to keep that system to kind of a minimum. You don't, especially if you have big codes, you know, if you have hundreds of thousands of lines in your software or lots of figures that you're putting into your manuscript, you want to somehow keep it so that it's not just a bunch of saved copies. Right, and so another thing is kind of keeping the overhead to a minimum. The amount of work that we as people need to do all these things that we want to achieve, we want to keep that to a minimum. Just want to make sure I'm not cool. And allow collaboration. I think I didn't actually see who said that, but I think that was highlighted. You want people to be able to work on the paper or the code together. And important is it's decentralized so that there's no one person that has the de facto version. And so that's useful for a number of reasons. And maybe you've seen this pilot in a higher and deeper version, which I think is, before I learned Git or subversion, actually the very first version control I was introduced to was subversion, but not CVS, so that's good. Is this was my first version control version, right? You have a final, you're done. You share it with your supervisor, and he has all his changes, or she has all her changes. And okay, so now you have to make a final with revision version 2, and so on and so forth. And you have copies of these, and you just have lots of files and lots of names that are at one point probably meant sense to somebody, but no longer makes sense. But at least you can probably bring in your sentiments about why are you going through this whole process. So I'm going to tell a little bit of what's called the Git parable, and this owes its credit to Tom Preston Warner. There's a link I've put in here that does the full parable. I'm going to walk through it. And the idea behind this story, and it's motivated, so the Software Carpentry motivates the story from the instructor's point of view, is that typically, and this is absolutely how I engaged with Git for probably the first decade I was doing so, is, at the end of the day, how you engage with a version control system, it's kind of like any programming language or English conjugation. You just do it because that's the way it's done. These are the rules. And there's no reason, wonder, or why about why things are the way they are. And so a lot of the times when you do kind of Git workshops or whatnot, kind of the approach is just dive in. Maybe you say a little bit about what version control is, but then you just go through and learn the commands that get things done a certain way. At the end, you say, ta-da, you guys all know now how to use Git. Congratulations, and go forth and do your coding and writing and whatnot. There's lots of downsides to that approach. Then number one is that I find, like, in science, we often encounter new things that we didn't anticipate. And so if all I'm telling you is just a list of commands, then what happens when you're in a situation that I don't cover? You're just kind of, you're in a tough spot. And so one of these in general is because if there's no kind of more explanation of the why behind things, certainly this is the case for a lot of like physics equations or whatnot. If I just have to memorize the equation, I'm not going to get very far. But if I understand kind of the why, how it's derived, then even as my memory starts to go, I can still kind of reapply that physical principle. And the same thing applies here to Git. And the idea of this parable is to give you a little bit more of that kind of intuitive understanding about why Git is the way it is. And then all the commands actually mean something. Like, you know what you're doing. You're not just typing the right things so that the syntax is correct. Instead, you're engaging with the Git program software so that it's doing what you expect. And you understand that. And then I think you're in a better position to, at the very least, learn, independently through online resources, as we all rely on for software, how you go about overcoming the obstacle I don't touch on in this session. Okay, so here's the parable. I think we can take, I'm going to watch the time. I think it will maybe only be 10 minutes. We're not going to do the whole parable today. I'm going to cut it off, and we'll continue the parable when it applies to what we do in the next session in December. So the parable is, let's imagine you are now at home. You have maybe no internet or anything. You just have a computer with some kind of text editor, and you decide you're going to write some software, a paper on a computer. And you want to kind of do good principles about doing this. And so you decide you want to keep track of your progress. Maybe your computer has a tendency of just getting bugs and crashing. You don't want to lose all your work. So you want to be making kind of a redundant system to be tracking what you're doing. You're trying to be clever. And you have a friend who is a photographer. And so your friend is telling you about, there's this family that comes in every single year, or maybe every month, and they just like to get pictures done in the same way. And so they're coming in, they want to see how the kids are growing up and see how that changes. And if I hit enter, what happens? Okay, not sure what happened there. And so hearing about this family kind of inspires you, like, I could do the same thing. If I could somehow take like a snapshot of my code, at some regular interval, or maybe more importantly, when things happen, then I'm good. I can always go back to those kind of snapshots. And so you decide you're going to do this. You're going to take snapshots of your code. You could just take a full copy, save it. Fortunately, hard drive space isn't such a rare commodity anymore. So this seems like a reasonable approach. And so you can imagine like you have some working directory of all your code. And what you routinely do is, you save versions, and you call it snapshot 01. You recognize what do you want to know about this? Well, you want to know when it happened, and ideally like what you did to it. So you put in a message that includes the date that it was made, date and time probably, and a message about why, what's new in this version. And maybe the very first copy was not going to be a lot there, but as you continue to do work, you have more information. Okay, the new date, the message, and then an idea of like what I did. And so this system seems to be working for you. Again, you have maybe a terabyte drive, and so nowhere are you approaching a memory limit. And so this continues and continues, and you're an avid coder, making lots and lots of snapshots every day. And so even just 10 days later, you've already reached snapshot 99. You're drinking a lot of coffee or whatnot. You're getting through this really quick. And by snapshot 99, you're really, really, really happy with what this code is doing. It's not full of typos. There's comments. You think that this is something that really should be shared with the broader community. You're like, this is going to be officially version 1.0, and you share it with the community, and they're so happy. There's confetti, and you celebrate. But the work is never done. There's always more things you want to do. So you continue doing work. You've now moved on to beyond snapshot 99. You're up to snapshot 106, 107, 108, 109. You're moving forward. And then, you hear from the community, thumbs down on your actual version 1, which is based on snapshot 99. Turns out there's lots of bugs in it. So again, this isn't based on the 109 version that you have a copy of. This is based on something that happened in the past. And so obviously it's time to fix the bug. The bugs, there's more than one, let's all be honest. And so, snapshot 109, that's a copy of the current working directory. So it's fine for you to kind of rework on snapshot 99. So what you'll do maybe is you copy snapshot 99 back to your working directory. So now working is a copy of the version that was released publicly. And you do some work and you fix some bugs, and you're like, okay, well, now I want to update the code. And now you're in a little bit of a problem. So far, you've been working completely linearly with this code. 109 comes after 108, 108 comes after 107. But now you're responding to problems that existed in the past. And there's things that you brought into the code in version 105 and 106 that aren't ready to be publicly available. You just want to fix the issues with the version that you made publicly available. And so you could call this snapshot 110, but there's a problem. It's the next version of the code after snapshot 99. And so what are we going to do with this? Well, the first thing that would be good is maybe we need to add more information to this little message that we're putting into our snapshots. And one of those things is, what is the parent? What is the previous version of this code? And so by adding that extra line into the message, I can see, okay, snapshot 110, sure, but its parent is actually snapshot 99, whereas snapshot 109, well, its parent was 108. And you go back and you put those messages into every single snapshot you've done so far. But still, it feels a little bit like difficult. How are we going to organize this whole system? Like, how do I know that I need to go back to snapshot 109 when I want to continue doing the big fancy work and not just the bugs? And so, existential crisis, everything you're doing in life is pointless. None of this was worth it. You obviously want to go for a walk. And so you go out for a walk, reflecting on your life, why are you in grad school, et cetera, et cetera. And you look up into the sky, especially if you're an astronomer like me, and sometimes trees get in the way of your walk. And so you're looking at trees and like, what beautiful structure and organization that nature has made in the structure of trees. And you realize like I can look at any one of these branches and trace it all the way back to the trunk, and all the other branches feed into it. And so it's a really, really simple approach. I can just pick any tip of these branches and slowly work it all the way back to the main branch of the code. Nature has inspired me. This is the same kind of thing that I'm kind of introducing by having this idea of putting the parent information in the file, right? This allows me as one parent to the next. I can then go from parent to grandparent to great-great-parent. And that's the same way that I can trace back my lineage in a tree. And so that's what you're going to do. You're going to invent the idea of branches. And apparently what this means is outside of your working directory, you're going to have to make a new file that didn't exist before. We'll call it branches.txt. And inside, it just tracks all the different kind of branches that I'm working on. And typically, you might see the word main or master, although that term is becoming defunct. Typically, you'll see main as kind of that main one that is like spearheading the most up-to-date versions of work. And then next to it, it just tells you which snapshot to go to. And then version 1 was this release version snapshot 99, but I've done more work on it. And so it points to 110. And so I can go to my branch file and see like, which one do I want to work on? And that tells me which snapshot to go to. And then I can copy that to working and continue the work. And then using the fact that I'm tracking the parent in each one, I can see how all of it connects back through time. One little thing about this is branches is useful, but the important thing to remember when doing branches is as you continue to work on that branch, you have to keep updating the file so that it's pointing to what's called the tip of the branch, right? The furthest along that that has gotten. And so what I'm saying is if I go, yeah, I can't. If I go back, so right now the most up-to-date version of maybe up-to-date code of version 1 branch is snapshot 110, and the most up-to-date version of main is snapshot 109. Say I continue to work on 110, I add a little bit more features to this that maybe are incorporated in 101 or 102, and I want them to be present in this version that's publicly released. So maybe I update to the next version of the code, snapshot, I make a save at snapshot 111. Its parent would be snapshot 110. Well, this branch is always supposed to be pointing to the most recent version of those. And so that's what would happen here. Maybe now 110 is still on this version 1 branch, now 111 is. So I have to update the branches file as I update the actual code. But every now and then, maybe you want to be able to point to a specific snapshot and just kind of let yourself know there's something special about that version. And so maybe and so that brings in the idea of tags. So basically maybe like somehow painting a specific spot on the tree and being like, I want to remember what that is. And so you decide at the same time you're making this branch idea that's always going to trace the tip of the code. Tags is a way to really just point to specific snapshots so that you don't need to remember them. Because I don't know about you, but I've gotten to a point where I just cannot rely on myself to remember anything. I get it in writing, and then I just have one place to look for everything. And so there's another file you're inventing called tags.txt. And here, even as I continue to do maybe snapshot 112, 113, developing the version branch, I know that the bugs that I fixed in version 1 was done maybe in snapshot 110, and that is version 1.01. That just is where I captured those bugs. So any questions about this kind of system that I'm making? Cool. So I'm actually going to stop the parable there. There is more to come in this parable because what about when I start wanting to work with multiple people? Do you always overwrite tags.txt or do you append it? Not sure why that switched. So I'm not sure what you mean. So, so really tags is just a list of snapshots that I care about with a name to kind of indicate to me why they care. So if I stop caring about this particular snapshot for whatever reason, then maybe I'll delete it. Maybe I make new branches that continue out and there's other snapshots that I care about, I could add to this. So this could be 20 lines long with all these different tags that just point to different snapshots. And then the branches, you always need to update kind of this list. So snapshot 109 points to the most up-to-date version of main. Maybe after doing snapshot 111, I'm like, okay, I'm done dealing with version 1 again. I want to go back to main. So I copy snapshot 109 into my working, continue to work on it. Snapshot 112 is made. It points to its parent, which is 109. I update the branches files. Main points to snapshot 112 now, 113, 114, that continues. The tags is really much more flexible. It's just a way of me, my mouse is being very sensitive, but it's a way of just kind of putting things that I care about, ways of pointing to individual snapshots of things I care. Yeah, I think so. Like a filter between me, instead of me having to go through 110, 120 versions or snapshots and try to remember when did this particular change happen. It's a way of like, I know I'm going to want to be able to come back to this version at some time. I'm going to put it in a file, and my version control system has a dedicated file for doing that called tags.txt. Anthony, does that kind of answer it? Sounds like things are cool. So far, you've been doing this kind of in isolation. Version 1.02 when I lost my sanity. Are you making a joke, or did I lose you in the idea of maybe going forward to version?
No. Just a joke. I'm being
like,
facetious, sorry.
Yeah, we don't want to put a tag to that because, and there is a part of the parable that brings in probably how you lost your sanity, which is you did some coding while you were drinking. And we'll come back to that maybe in December. So I think for what we're going to be able to cover with the rest of today, it doesn't entirely make a lot more sense to continue with the parable. And so I'm going to continue that kind of story that kind of really feeds into the whole, like kind of a logical progression of how the system is expanding. We'll continue that next month. And so for now, I just want to kind of focus on what we have already achieved just in this system. And so we want to save snapshots for our work. This system does that. In Lingo, in version control, we call these snapshots commits. In Git and typically in version control, that is the word that we use rather than snapshots. We want to be able to go between previous snapshots and not lose where our most recent work is. We saw an example of that. As long as you take a snapshot of what things are right now, well, now I have that snapshot or I have that commit. So now I'm in a position where I can copy past commits into my working drive, and I haven't lost my work, and I can go and interact with things. If I really want to make edits there, I could maybe define a new branch and work from maybe snapshot 77 when I had this really good idea and threw it away thinking it was garbage. Well, actually, it's really good, and I could continue doing work there. And I'd always be able to go back to the other branches and other tips or whatnot. And yeah, and so you want a system that kind of helps kind of explain that organization. And so we've introduced that with the branch idea. But so far we haven't discussed collaboration at all, and we won't do that. And so far, every time we do this, we're making a full copy of the entire working directory and making a snapshot of it. And it turns out that's unnecessary. But again, you have a hard drive with lots of terabytes, and so you don't need to worry yet maybe about doing this, but just wait until you start collaborating with somebody that likes to travel a lot. We're going to get to a point where maybe you do need to start worrying about just how much file size this is having on your computer. So we're going to come to that in a bit. Stay tuned. But are there any other questions about kind of this framework for making a version control system? So we've already discussed a bit about why, there we go, why you might want to only do changes. And so, Software Carpentry does talk a little bit about how a system that's really only tracking the changes that are happening into a file, that is something that's efficient to do. And you could do with systems where maybe if different people are making different changes at the same time, you can incorporate them at the same time into the file. And so that's the beauty of version control, and we'll help motivate that a little bit more. And there is a bit of history here where talking about Git and Mercurial and how Git really is what's most used. And so just as a little bit more of a motivator for using a system like version control, You could imagine, if you're doing a paper, imagine you drafted an excellent paragraph for a paper you're writing, but you later ruin it. Version control allows you to go back and maybe recoup those priceless lines. I absolutely hate writing and then losing it and then trying to rewrite what I said before when I know I've done it before. Word, you have crashed on me too often. But yeah, save your changes. And then think about how you would incorporate that in if there's multiple authors. And so those are the main salient points to come from what we've talked about already. Version control is basically an unlimited undo and redo and allows multiple people to work together. So let's dive in to initializing your Git. So what we're going to do is start up our Git system. And so I'm just seeing there is a chat. That's not a Windows OS. No, I'm not using Windows, I'm using Mac. But everything we're doing today should work fine if you are on Windows. But that's what we're here for, to work it through together, and I can try to help debug Windows issues as they appear. And so if you followed the directions on that I linked to in the invite, and you downloaded Git for Windows, I believe it came. There's two different modules. You can either use it, you should have set it up so you can use it through MS-DOS, so the terminal on a Windows machine. And I think there's also some GUI, some software that allows you to do the work in a Windows machine for doing Git. So some of the first things you want to do is you basically want to let your Git config know who you are. So you want to just like configure like, who are you? Remember, as we went through the system, we kept tracking kind of the date things are happening. Well, as you do collaboration work, you're going to want to also be tracking who's responsible, right? And we're going to motivate that a little bit more next time. But to get on top of that, we're going to use this Git config statement. Basically, you're just setting up your settings for your Git on your computer. And by doing config global, this is going to apply to any other Git repositories that you do. And so I've already done that before. And trying to think, is there a way for me to just show you my settings? Probably. So we can use the help command to find out what those are. And yeah, so I can just do like, let's see what they are. Get config get user.name. Apparently, oh, it really cares. I think I could do. No, it really wants me to be in a git config to use that command. I would encourage you to set this up now. Yeah, do your git config. Don't, unless your name is Vlad Dracula or the Wolfman, I recommend you use your own name and your own email. I can just see what mine is. I know that when you do this, it makes a git config file in your home directory. And so when you set these parameters, it will be setting these values for you in your global git config. And so you can see what my name is and my work email. This is not my Queen's email, but I've been using GitHub for so long, or I've been using Git for so long, it's come through different jobs. Your work email changes. So I made a kind of a more stable work email that gets to change. Not that you can't change it in the future in your account or whatnot. Another thing that I recommend is, well, we'll get there, but I already have it set, is Nano is a really good editor. It's always in your terminal. All three systems have access to it. And it tells me, if you've done Emacs, you have to remember what all the commands are. Nano tells me those commands at the bottom of the page. And so I don't need to remember anything to use Nano. And as you're probably sensing, that's a good rules to live by for me. If I don't have to remember it, then I'm going to be happy with it. Emacs is a nice OS. Yeah, if you already use GitHub on your desktop, you're probably already set up. Right, so please use your own name. If you don't some people maybe don't want to be using these emails. These emails will be publicly available on your account on GitHub. GitHub can provide you your own email under like a users.noreply.github. I believe when you make a GitHub account, you can choose to use that as your actual username. And then you would go on to GitHub to see what those messages are. And just, there is one issue, which can be, I think, on Windows machines, that it's kind of like a new line. Systems sometimes, by default, whenever you put in like a final line, you need that carriage return to put it in. And so this is a word of caution that sometimes on different machines, you don't automatically get that carriage return. And so a way that you could set that up, that there's always a final carriage return, you could do this too. You absolutely can. You can always run this command again and change that. The only thing I would say though is that you do want it to match the email that you have on your GitHub account. There's a reason for that. When you start trying to collaborate with other people and things are then connecting usually through GitHub, then it needs to match. And so if you change the email that's on your account on your GitHub account, you should update it on your system. But you can absolutely do that change all the time. And so these are commands you might want to do. Yeah. These are commands you might want to do to just kind of focus that. And then I really recommend setting the default editor for your system. So putting this in, and I could just do this. I mean, I could be doing this as well if I know how to spell. So I could be doing this command as well, username, and then Mark Richardson, and it's just gonna set it. Apparently this page recommends nano with a -w command. So I might actually do that. I already use nano. I recommend all of you use nano as well, but if you have a favorite, go ahead. So now when I get this config, you see that it actually has updated this file to be the changes I made. The default is Vim. My assumption is if you ever got into Vim, you'd still be there and you wouldn't be able to join today because you'd have no idea how to get out of it. At least that was the experience of people for years before the internet existed. But I really recommend you do not stick with the original, which is Vim, unless it's your favorite. But nano is a very good, simple approach, and that's what I always do. And so there is a warning message here about how you get out of Vim. If you're in Vim, you'd hit escape to get into your options, which gives you the colon. Oh, you have to add the colon, then Q, and then exclamation mark to mean you really want to do it. There is a default, and I would recommend this. The default for a lot of Git is actually to start new branches with master. Basically, that's a pretty unfair term. It's certainly becoming more inappropriate. It does relate back to slavery and this idea of somebody having ownership over the other branches. And so the Git community has moved on to, now we call that the main branch. And so there is a disclaimer about that history there. And in lots of coding experiences, especially like with multi-threading, there's an experience of using the master and slave even in those names conventions, and that's all changing. Oh, and apparently there is a command that I couldn't find, which is just git config list, then puts out basically all the different commands that I have in my config file. And so it's a way of checking everything that we did. Some computers require a proxy server to work, and so, but we won't run into that problem now, and so I say that you don't need to worry about it. And you can always do this git config -h or -- help to find out the directions or other commands you can give config, as well as git just help. And it tells you some of the more general things that you can do with git. As always, I don't need to memorize all my commands. I can just remember git help, and then that does the memorizing for me. And so these are systems that I'm obviously engaging with quite a bit. And so with that, kind of on the back end, your Git system is set to go, and we're able to move forward. And so what we want to do now is create our first repository. And so the idea behind this, right, is like in that parable, like basically this is the moment where you're saying, hey, this is a process I want to do. I want to use version control. And so we're going to just do this work on my desktop. I'm going to say, so what I'm doing there is I'm changing directories to my desktop. I say I want to make a new working project for this work. And I'm going to call it Planets because it's Dracula, the Wolfman, and Mr. Mark working on how we go to Mars and whatnot. And then I'm going to change directory into my planets. And I do recommend doing this on the command line. That's how I engage with Git. I think there are GUIs that help you do this, but I do like doing it through the terminal. And then basically you need to activate the Git systems. Like this is a process where I'm doing work or I'm writing software or I'm writing a paper and I want to be tracking it. And so git init will do that work for me. So basically it just says, okay, you've initialized this repository as an empty, as a new place you're doing version control. It's confirmed that's happening, but it's also telling me right now you guys are empty. And so sure, I've started the system, but there's nothing in there to track. And so just to show that, right, there's nothing. ls shows me the list of all the things in my directory. I see there's nothing there. If I do ls-a, that forces ls to show me all files, including hidden files. You'll see that there is a new file there, .git. Inside that directory is basically all the work that the software is doing on the back end to track all the things. And so if I was to delete that, it'd be equivalent to me having never done init. And so if you ever want to know how you completely undo and remove everything you have in your Git repository, you would have to remove that .git file. And so just make sure that that's what you really want to do if you're doing it. Right on. And so one thing to just force, we're going to change the default branch to be main. We want the default is usually default. Depending on your system, the default name is always going to be main, and we forced it to be main. But this is a way of basically saying, like, my work, I'm starting my work on that default branch. We're going to continue, or that default branch, which I'm calling main, and we're going to continue all of our work doing that. And so the command for basically changing your branch is checkout -b. And so I'm just saying git checkout -b main. So that's basically saying the branch I'm going to be working on is named main. And so I switched to a new branch named main. And you can see that that's the output you should get. And everybody should have had that back. Now, one thing as you're doing changes, you want to know, have I made any changes that aren't kind of snapshotted yet, that aren't in a commit? And git status is the way to do that. And it's like, well, what are you talking about? You don't have any snapshots yet. You don't even have any changes yet. There's absolutely nothing done. And so we're now in a place where we can start doing work. And so again, we're getting the exact same output that the software or the web page tells us. There is a bit of an aside, just one more thing. As I continue to do work and I make commits, it will track all folders that are made and files inside those folders. So for example, say I make a directory called Mars, and now I do git init in here. So now it says, okay, I've made another Git repository inside a folder. It's worth saying that this can cause a bit of issues. There's going to be self-referencing that, like, the Git repository at the parent one, Planets, is going to care about this one. And so it can cause some issues. And so you don't need to do it. So this is redundant. And so yeah, so if I do git status here, or oh, I haven't made it yet. So yeah, if I read ahead. Right. What that's saying is if I instead had done this, make directory moon, so this is not inside planets, and say moon is where I want to do more. And if I did git status in there, then I get like this is not a repository. But because we did do that git init in here and in Mars, both of those git statuses didn't have an issue. If I learned to spell, then I'd be able to show you that for sure. One issue, though, again, is we said that putting a git repository inside a repository is bad. It can cause lots of issues. And so again, how would I undo that? Do ls-a .git. I want to remove that. So there's files in it, so I can do remove -r .git. Be careful with that command. It's now gone, and so now it's like normal. So that is one way to remove, and it'll be gone. But be careful with that. It's a lot of power. All right, so Greg has highlighted a GUI front end. Is that friendly to all software, like all operating systems, Greg? Cool. I'll have to explore it. I've always done this either through GitHub or through my own terminal, and so it would be interesting. And maybe if there's some time left today, then maybe we can explore that together. Cool. So all we've done at this point is just learn how to initialize, basically like, hey, here's an area where I'm going to be doing work and I want to track that work and understand the kind of the backend files that it's making for that and how you can start interacting and understanding like, what's this current status of my work? So now we want to move forward and actually start making changes and understanding where those changes are coming from. And what I'm seeing is these sessions are taking a little bit longer to go through. And so this might actually be as far as we get. And so we'll see, and that's the benefit of having 3 parts. And so we're here, we're already in planets, and now I want to make my first file. In fact, I made a directory which I don't even want. So we're going to remove that directory. So I have this blank canvas again. And so I'm going to make a mars.txt file because Mr. Dracula wants to start considering about making maybe a mission to Mars. And so, when it comes to Dracula, he loves red. And so he just makes a note that Mars is cold and dry and definitely his favorite color. And so I see that Mars is there. I'm going to actually, if you guys are maybe more used to like seeing GUIs, examples of what this stuff looks like on a file system, I see I have this planet, and then there's Mars and the context of Mars. All right, so I've made this file, and I can look at its contents. Again, it's cold and dry, but everything is my favorite color. And now let's do this git status. So I've made changes to where I'm doing this work. Of course, I haven't committed anything yet, but what I am seeing is there's apparently an untracked file. And that is this mars.txt. I see it's in red. And so there's kind of 2 things that are going on here. First off, it's recognizing there are changes. Great. So it's highlighting that, but it's saying it's an untracked file. And the reason for that is the system doesn't even know that Mars is a file that belongs to this repository. And so we need to do that. We need to git add mars.txt. And what this does is it basically adds that file both to its awareness as being part of the code that I'm doing or file system that I'm doing, but it also puts it in what's called the staging area. And I could have added that to the parable, but what you can imagine is maybe you get really busy one night and you end up doing work on different features, but you really want the snapshots to document just incremental change. And so by allowing a staging area, I can just move the work I really want to capture in one snapshot there and then use that staging area as like, here's a snapshot of what I care about right now. That gets triggered, and then I can move the rest of the changes to the snapshot or to the staging area and make a snapshot of that. And the nice thing is that Git behind the scenes gets to do all that. tracking. So that way I can kind of undo these changes one at a time. The better way to do this, and before you would even make a staging area, is just being really precise. Like I'm only going to work on one thing and make snapshots as I change this. But as we all know, sometimes you're doing one thing, you have an idea, you're going to go dive into that other feature and things just happen. Staging areas allow you to kind of have that control. So we're going to do git status again. And now it's like, okay, the R changes to be committed already. So they're in the staging area, they're ready to be committed. And what is new? Well, there's a new file that's been added. And so you see that this is a new file. And so now Git, because of the staging area, Git knows, what's Max saying? One second.
We're all good. I think we're fine on the end. I can help.
Okay, I was just worried it might be affected by the recording or something.
I will not affect the recording. It just the polls at the end, and I can take care of that. Thanks, Max, for letting us know.
Okay, so this is now ready to go. And what we want to do is we want to make that first snapshot. So we're going to do git commit. And technically speaking, this is all you would need to do to make a snapshot. But when you do, remember, you want that message of the why. Why did you do what you did, and what did you do? And if I just did git commit, it's going to open up a text editor, the one that we set as our setting, to then be able to record that message. That's 2 steps on one will do. So what Software Carpentry does, and what I always do, is you can add a -m, which basically says, I'm just going to tell you that message right here and now. And then I can put that message in here. And so apparently I started notes on Mars as a base. And I see that, okay, great. So you've made a commit. And I also see there's this weird string of numbers. That's actually going to be the ID for this commit. And we're going to come back to why that, well, why isn't it just commit 00? We'll come back to that when we start entering collaborations. But if you could imagine that, what if somebody else was working at the same time, we both had commit 0, then we'd run into a problem. Like we'd have to start renaming them. This is a unique identifier that's unique based on my name, the date that's happening. It's basically using a hashing code to come up with that number. And so this is a unique identifier. No matter what, it's basically impossible that this is going to be, it's going to be the same as somebody else's commit. And it's actually much longer than this. These are just the first 7 characters. It's very unlikely that that's going to overlap with anybody. So let's do that git status again. Let's see what's going on. Okay, I'm on branch main, but there's nothing to commit. Everything's fine. It's like, okay, well, what about the work I've done? Well, look at what's kind of been done. Look at all the snapshots. Git log gives you all that information. And so here it tells me, here again, I told you that that unique identifier, it's much, much longer to make sure it is unique. Typically, it just shows you the first 7 characters because that's all you need to usually identify one. Head is basically what I'm working on right now, and it currently points to the main branch. Who's the author? Okay, that's me and my email. What date did this get done? It's the current date and the time. And what's my message? And so this is, telling me everything that we've talked about in those messages that we want in a version control system. And so Vlad got a slightly different message. He got a completely different string because, again, that's dependent on both the time, his name. It's basically a function that takes all that input and spits out a unique indicator. Okay, so everything's here. Where are the changes? There's still just the file mars.txt, but everything about the version control aspect of this is sitting within inside Git, which is to say, like, that first original snapshot is basically a blank repository, right? So right now, the only difference is really that I've added a file and it has content in it. Now, what if I want to make some more changes to Mars? Maybe I'm just going to do some input right on. Yeah, we're gonna skip ahead a little bit. Really? Good. Whatever. We'll get that in a little bit. My Nano, by default, I make it so that it makes a backup of files, which is totally not necessary when I'm using a version control system. So I'm going to fix that. Yeah. Okay, ignore that. So now that won't happen anymore, which would just cause some stuff. So now that I did that, we can see the changes in Mars.txt. There's 2 moons, maybe a problem for Wolfman. I mean, that depends. Maybe he likes being a wolf. We can do git status again and see, okay, there's a modified file. So this is a file that it's already tracking. Remember before we had an untracked file. So this is seeing that a tracked file has changes, but it's saying no changes added to commit. So basically if I was to do a commit right now, nothing would happen. And that's because of that whole staging area. So the first step is if I was to do a commit, I'd have to add it first and then do a git commit. But before you ever do a commit, it's usually a good idea to double check what are the things that are actually different right now. And so before I do that, we're going to use this git diff command. It's just a really, really, really effective way to, just realizing I can't see the chat or whatnot. It's a really, git diff is a really effective way to be able to see what has changed. And the default for, if you just do git diff, is to look at the entire repository and compare that to the last commit. And so it does look a little bit cryptic, but it's definitely giving me some really, really, really useful information. It's doing a bunch of stuff on the back end. And so, especially if you've used diff in a Unix command, you're probably familiar a little bit with how this works. So what this is telling me is, okay, there is a difference between the file mars.txt and what's been committed. It's going to compare the 2 differences. It's saying, well, in the, and this is because I didn't add an ampersand or a new line, but it's saying in the original version, you have subtracted a blank line and you've added in a new line. That's the 2 moons may be a problem for Wolfman. And actually, one thing I'm seeing there, so I didn't actually add an explicit new line, but well, there must have been 2 lines before. Yeah. Right on. So what you see is, okay, you've added this 1 line. The 2 moons may be a problem for Wolfman. And so nice colors and everything to give me like an understanding of what those differences are. So it's really, really useful. So now if I want to do changes, I would do git add that file. So now if I do git status, I see that, okay, I have modified a file that means ready to be committed if I do a commit. Just curious. Now, if I do git diff, I actually don't see a difference. And the reason for that is because what git diff does by default is actually compares the staging area to, it compares the staging area to what is currently the version of the code. So even though I haven't committed, git diff is comparing, like right now, there's no difference between what stage to commit and the current stage of the file. I want to make sure there is a different command I can do. Software Carpentry suggests that maybe they would have got a different answer. So yeah, they don't actually show you doing the git add, but we're gonna, in a second, we're gonna actually be able to look at tracking those changes a little bit more. But that's just to say that git add has added it to the staging, and now we're going to commit. Git commit, and add concerns about Mars's moons on Wolfman. I wonder if Deimos and Phobos would have the same effect on Wolfman as the moon does.
If you scroll down, it does show that you get add, because it was showing that it won't add it because it wasn't added previously.
Oh, look, they preempted my issue. Exactly. So if I had done just the git commit, it will say, there's basically no changes to change. And so you get that error. Thanks for pointing that out. And so they have to add it and then commit. And then you get that. And so now we're caught up to where it is. So again, this is something I've already said, but this idea of the staging area is just Git actually requires that you move things to the staging area first before you commit. There are other arguments you could give to commit that basically just forces it to add everything. This is like the -a option or -all. I really don't recommend that. If you have experience with Mercurial, the Mercurial really does the commit and stage at the same time. And when I went to Git, it was quite the learning lesson to realize like, oh, I have to add this every time. What a waste of time. Until I suddenly realized like, wait a second, no, I changed so many files. I only want to capture this one change that I did. And so I actually love that feature now. And I never personally use these kind of extra commands. I manually am adding what I want to add to that repository, that snapshot or commit. And so there's a nice picture here of just showing like that git add kind of puts it in the .git file saying, okay, this is what's ready to be committed. It's staged. And then when you do commit, it moves it here. And so, so that's a really, really good point. And we'll do that right now. So let's open up Mars. I've already committed it, so we'll have to do two changes. Our friend the mummy is getting involved. Apparently doesn't like the dryness of Mars. Okay, so again, we've made the change to Mars. That last line, git diff, we've already seen this. It's going to highlight that difference because it's the difference between what's in the commit and, it's a difference between what's in the staging area and what's in the current repository. And so the current repository is adding it because it hasn't been staged. And so we're going to git add. Git diff has nothing. Now, if you want to instead see what's different between what's staged and what's in the current output, then you could do this staged. And then I'm going to say, and Connor wants to see the world burn. So it says, okay, there is a staged modification version of Mars. There's also a further modified that's not staged. And I can do git diff, and I can see that difference. I can do git diff staged. And that just shows, again, the difference at staged. Now, if I was to commit right now, I'm only committing what's staged. So what's going to be tracked is what I added to the staged area. So this final change of Connor wanting to see the world burn would not be captured. So if you're staging a file and you're not ready to commit and you continue to edit, you have to remember to restage that file. So I can re-add it and do git status. And now it just has modified. Do git diff, there's no difference. If I do git diff staged, now I'm going to see those two changes that are ready to go. And so when I add it this time, now the whole change would be captured. If I added it before, only that first stage change would have been captured. Cool. All right, so sure, for the sake of following along, just as things compared to what's in the example, I'm going to remove Connor wants to see the world burn. He probably doesn't want that to be so public. We want to keep that aspect of Connor secret. And now if I can do git diff, and you'll see that now that line was removed. Again, I made a change. So I need to add that back to the staging area to capture that change. I see that now there's no difference between the staging area and my file, and I'm good to commit. And so grab this instead of typing it out. Now, as we've been doing this, and I think this file does do it now. Yeah, it does. So again, git status, nothing there. Everything's ready to go. We've been doing a lot of changes. How do I want to see this? So that git log command again is that resource of showing us all the changes. Git log is actually a really, so it's a useful tool, but it will show you the entire log. So all snapshots that you've made at any time. And that can take up a lot of text. And so that could be annoying later on. Yeah, and so the different colors are useful. I don't know if you can see that, certainly up here. This is telling me that at least on some systems, if the git log is really, really long, it's now smart and it'll open up equivalent to like looking at more or less on a Unix command. So it doesn't just throw all the text, but instead it's like an actual window. I would suspect the way to force that to happen is if I make the window smaller than, than the actual text. And so what it does instead is it's plotting it out to fill the window, and then I hit enter if I want to continue, or just hit Q and I can exit out. There's some nifty like little commands, like little arguments you can pass. Say I just want to see the most recent. Git log -1, we'll just do the most recent. Again, that sounds like one more thing to remember. Instead, personally, I would have just piped it to like head, and then that'll show me the first 10 lines of the git log, which is obviously going to be more than one, but you know, it gets me that one and a little bit more just for kicks. There's also, you can do like a one-line kind of summary of each entry. Git log, one line. And again, it's like one-line version of each of those entries. Doesn't have all the information, doesn't tell me the author, doesn't tell me the date. It's just capturing kind of the unique identifier indication if that's where the most recent, that's where like the tip of the work is, what branch it's on, and then those helpful messages you've been doing. So a nice, really efficient way to just search through like, what are those messages that I've been keeping for myself? Say I'm searching for a particular change that I made, then that's quite useful. Alrighty. Now there's not nearly enough here yet, but if you're doing lots of different branches and lots of collaboration, one line. It actually has a system with the graph that can show you some of the kind of cool graph about all the different branches and how things came apart, came back together. This repository is far too simple to be showcasing that. If you wanted, I think, sorry, I think it's final Git development. I'm just curious to see this now. Let's try that same command, git log one line. And it was graph. Apparently my messages are too long for this. Still too long. And here you can see, like right now, there's really, I'm just working on dev. So we're developing some new stuff for this software. But when did dev come about? Well, it branched off from main, and you can see there's actually some collaborations of these different people that are working on this of different colors. And so you can see this kind of whole system and history of this version. So each one of these lines was a commit. And some of them, yeah, some of them are involving different branches and different people and whatnot. So you can see that a little bit more in action there. Cool. So just want to see, we are approaching out of time. I think we're nearly at the bottom, so we'll just plow through and finish up the last 6 minutes. Although we do have a poll to do, so let's just make sure we do have time for that. So one note that is, so I told you already that if you make new directories in here, so here you can see this is spaceships, GitHub will track all the files in those directories, but an empty directory does cause a little bit of a stink. So I made it. Git status doesn't show anything. I want to add, it doesn't even say like untracked file, right? It just says everything seems fine to me. But I can still add it in. And when I do git status, it actually still shows there's like really nothing to commit. And so the reason for that is it really doesn't care about anything if it's just a directory. It's like, well, there's nothing in it, so you don't actually care that I follow it. And so it doesn't do a whole lot. So sometimes you'll see like a file, people will put like a .git keep if they really want to force, like I could go into spaceships and do just make an empty file with the touch command. So touch just basically says like, I want this file to exist, it's completely empty. See, it has 0 bytes, but it was made at this time. So now if I do git status, now it says, okay, there is an untracked file and it's actually inside spaceships. Even though I've added spaceships, it's tracking the files, right? And it's a hidden file, so it's not going to show it. But I can add spaceship and it recursively adds everything in it. So now I can do git status and see now it's like, yeah, I see that file. I'm going to track it if you commit. Oh, look, it does touch as well. And there's absolutely nothing, right? Like I chose the git keep just as a way to say like, do keep it. They ended up showing this example with Apollo 11 and Sputnik. They just make empty files, they add it in and they're all tracked. And so let's just do that a bit. We'll touch Apollo 11 and Sputnik 1. Those are very different timescales. And so now I can re-add spaceships and git status. I see those are ready to go. And so git commit -m, add some initial spaceships apparently. And I see that those are added into the log file. Now the issue I'm seeing though is if I use the git log.head, I lose all the pretty colors that tells me more stuff about this. And so yeah, maybe git log -1 is the better choice. So there are some activities in here you can do that take through just some examples of this. I encourage you guys to do it if you want to explore a bit more. But just wrapping up this bit, we've seen this git status is really, really useful for just showing you like what's going on. Do I have things to change? Git diff is really, really useful to see like what's about to be committed if I commit, or what was recently staged that's different. The importance of git add to put things in that staging area, and then ultimately that commit command for both saving it and the really useful -m command for like making a message then and there. I should just now mark once to see the world burn. I'm going to add that. I'm just going to commit. And you see it opens up Nano for me and it gives me this whole message. And so it gives me that space to then add the commit, showcasing commit. And I save it. And now I can do git log -1. And you see that it's captured it the same way that it would if I did it with the -m.